All right, let's jump right in. Today, we're going on a developer's journey through the complete lifecycle of an application on Kubernetes. We're going to see how it goes from an idea to something that can run securely and automatically at a massive scale.
I mean, you've probably wondered about that, right? How do these massive apps we use every day just work, even with millions of people hitting them at once? Well, the secret, a lot of the time, is a technology called Kubernetes. It's really become the standard for managing big, complex applications for a reason.
So let's start where every project does, at the very beginning. Before we can do any of the cool stuff, we have to get our application running on the Kubernetes grid. This is step one.
I love this analogy because it's so true. Think about it. A modern app isn't just one thing. You've got your foundation, that's your database. You've got the walls and plumbing, that's your back-end logic. And you've got the paint and windows, your front end. Kubernetes is kind of like the general contractor that helps us put all those pieces together into one solid working house. Now, to build this house, we use a few key building blocks. First up, you've got pods. These are the absolute smallest things you can deploy, and they hold your application's code. Then you have deployments, which are basically the blueprints. They tell Kubernetes, hey, I need 3 of these pods running at all times. And finally, services. Pods can come and go, right? A service gives them a single, stable address so the outside world can actually find them. So our house is built, the app is live, that's awesome. But, in the real world, software is never really done. So what happens the moment you need to push a bug fix or a new feature? How do you update it without knocking the whole thing down? And that brings us perfectly into our second section. How do we keep our application evolving and getting better without breaking it for our users? No downtime allowed. Okay, this is where it gets really cool because we have options. The most common one is a rolling update. Kubernetes just gradually replaces old pods with new ones, one by one. It's perfect for most standard updates. But what if you're a bit more cautious? You could do a canary deployment. Here, you send just a tiny bit of traffic, say 5%, to the new version. It's a great way to test a risky new feature in the wild. And then there's blue-green. You deploy a whole new, identical version of your app right next to the old one. Once you're sure it's good, you just flip a switch, and all the traffic goes with the new version. The best part? If something goes wrong, you just flip the switch back. Instant rollback. So we're in a good spot. We can push updates safely. But there's always another challenge, isn't there? What happens when your app suddenly goes viral and you get a massive flood of new users all at once? This is where Kubernetes really starts to feel like magic. We're talking about handling real-world, totally unpredictable traffic spikes by scaling automatically. And the secret sauce for this is something called the Horizontal Pod Autoscaler, or HPA. You can think of it like a smart thermostat for your app. It's constantly watching the demand and automatically adding or removing pods to keep things running just right. So, how does it know when it's time to act? Well, it keeps a close eye on important metrics, usually things like how much CPU or memory your running pods are using. And here's a perfect example. Let's say we told the HPA, hey, try to keep CPU usage around 50%. But suddenly, a wave of traffic hits and the current CPU load shoots up to 85%. The HPA sees this and immediately knows it's time to get to work. And its response is immediate. It doesn't wait for a person to intervene. It just starts spinning up new, identical copies of your pod to help share that extra load. And boom, here's the result. The HPA scales our app from 1 pod to 3, just like that. Now the load is spread out and the app stays fast and responsive. And, this is key, once the traffic dies down, it'll automatically scale back down to save you resources and money. You only pay for what you actually need. It's a really beautiful closed-loop system. Okay, so our app is a beast. It can handle updates, it can handle huge traffic spikes, but we've been so focused on performance, we've forgotten about something absolutely critical: security. Which brings us to section 4. It's time to lock the doors and windows of our application, because if you're not secure, none of that other cool stuff really matters. One of the absolute biggest security mistakes you can make is mishandling secrets, things like API keys or database passwords. Just putting them directly into your code or a config file is a huge no-no. The right way, the only way really, is to use a secure, centralized system that injects them into your application only when it needs them. And a fantastic tool for this job is HashiCorp Vault. It's built specifically for this. It not only stores secrets securely, but it can do something even cooler.
It can create dynamic, temporary credentials that expire after a few minutes or hours. This dramatically shrinks the window of opportunity for an attacker if a secret ever gets leaked. It's a total game changer for security. Now, besides our secrets, we also have to protect data while it's flying across the network. And for that, Cert Manager is an absolute lifesaver. It completely automates the painful process of getting and renewing TLS certificates. It just works in the background, making sure your site has that little padlock icon and that all the traffic to and from your users is encrypted with HTTPS.
So let's take a step back. Our app is now scalable, it's secure, and we can update it gracefully. But look at all the moving parts we have now. How on earth do we manage all this complexity without a whole team of people working around the clock manually?
And that brings us to the final and maybe most important stage of our journey, putting this whole system on autopilot. We're talking full automation and getting the insight we need to trust that it's all working correctly.
The philosophy that makes this possible is called GitOps, and the idea is actually really simple but so powerful. Your Git repository, the same place you store your code, becomes the one and only source of truth for what your system should look like. Every single configuration detail lives right there in Git.
And the workflow is just beautiful. A developer wants to make a change, they push it to Git just like code. A special tool running inside the cluster sees that change, pulls it down, and automatically makes the live system match what's in the repository. That means every change is versioned, peer-reviewed, and if something goes wrong, you can revert it with a single Git command. It's amazing.
But you can't just automate things and walk away. Automation without insight is just flying blind. And that's where observability comes in. It's really two sides of the same coin. You have monitoring, which is like the smoke detector. It tells you that something is wrong, like, hey, your error rate just spiked. And then you have logging, which is the detective work. It tells you why it's wrong by giving you the specific error messages. You need both to have the confidence to let your automated system run.
And that really brings our entire journey full circle. We've seen how an application can go from just an idea to this incredibly robust, secure, and automated system. Kubernetes gives you all the building blocks to be resilient. So the real question to leave you with is this. Take a look at your own projects. What's the weakest link in your deployment pipeline?